Hello everyone, in this video I'll be explaining you the problem Blackslex and showering. So after the IMO medalist friend, uh, after his IMO medalist friend showered for 2 hours so that he does not have to shower this again. This way Blackslex will be late for classes. So in order to get to class, Blackslex must take the crowded elevator to many floors in certain order. Because he is a hacker, he can skip visiting up to one floor without other people knowing. His time taken is the sum of the absolute difference between consecutive floor numbers. Find the minimum time taken given that he can skip up to one floor. Okay. So more formally, given an array A1, A2 up till AN of n integers, you can choose up to one index, let's say k, which belongs to 1 to up till n, to arrays such that the sum will be bi minus bi plus 1. Okay, and this sum is minimized, where b is basically a1, a2, ak minus 1. Since we have removed that k, so there is no ak and it is started from ak plus 1. Okay, so is the array after erasing element ak. Report the minimum sum. So don't worry, I'll be telling you what they're saying. It's like yeah, we have input and we have test cases. For every test case we have integer n denoting size of the array, and then we have n elements. Okay. So let's take examples. There are 3 examples. Let's take first one. We have 4, 15, 179. So let me go to the board. So we have 4, 15, 1, 7, 9. N is 5 and this is the array. Okay, some of you had commented audio quality was that bad. So I just made setup in such a way that I can look now audio like how it is. If there is any bad, then I can figure it out on the go. So yeah, let's first focus on the problem now. In the problem statement, what they have given is we have n floors. It's an elevator. We have n floors. And it's very crowded in the elevator. So Blackslex, what he can do is he can skip one of the floor. Okay. He has he's a hacker, so he can skip one floor, and while doing that, it's the work done by that is going to be given as summation of bi minus bi plus 1, where I is from 1 till n minus 2. Okay. And what is b array? B array is such that a1, a2 up till so on, ak minus 1. Then we have ak plus 1. Ak we have skipped it here, as you can see. Then we have an. What is ak? We have chosen k as indices from 1 up till n. We have chosen only one, which is ak, such that he skipped that floor. Blackslex, he have skipped this floor. So now this summation is done by this thing. Okay. So we have to find the minimum summation of this. Let me again break down the problem. What they're actually trying to say is they have given this array A. So now you take one sum. Take one sum as first element you take, then minus second element, then add, then you're taking second element and third element, then add third element, fourth element you're taking, fourth element, So this is the sum required when the Blackslex did not skip one floor. Okay, any one floor. So whole floor is moving. That's why this is a sum. Okay. So its sum will be something as you can see. Um, this is 11 and this is 14. Okay, and this is 6 and this is 2. So this is 25 and then 8, 33. Sum is 33. But you can skip one floor. If you skip one floor, your summation is going to reduce. We'll see how it is going to reduce. So what I'll try to do is we just focus on which we can skip any floor. So we'll have to, let's say if you skip 4, so 4 will no appear in the sum, no more appear in the sum. Skip 4. So I'm taking the first element. There will be pattern you see. First and last element will have certain pattern, and then these three elements will have certain pattern. When I skip first element, so in the summation entire you see first element has appeared only once. Okay, so this part is no more valid in the sum because it's like you have removed this. Now your array is starting from this thing. Okay, so it will start from here. So you are removing this. When you remove this, what is the value that from this sum you are getting to reduce? It is 11. So if you reduce 11 from 33, your sum is going to be 22. Okay. Now let's try to skip 15. If you skip 15, so in this entire sum, if you see, 15 has occurred here and here, right? And it is the middle term. It is not first term or the last term. It is middle term. So whenever it is the first term, this operation summation, one summation will go. But if you are taking the middle term, it is appeared 2 times. Why? Because this 15 is taken by this 4, and this 15 now will take this one. So that's why 2 times is there. So it's like you remove these two. Okay, when you remove these two, it's like 15 is gone. I'll remove for a second. I'll remove. 15 is gone, and your array from here it is looking fine. See, 1 minus 7 is there, 7 minus 9 is there, but still you have this 4, right? So you remove these two and then add this 4 minus 1, right? 4 minus 1 you will be adding. This you are skipping. It's like that way. Okay. So now what we are trying to do is, in your sum, whatever 33 was there, you remove these two. 11 you removed, so 22 you have, and 15 minus 1 is 14. 22 minus 14, if you do, that is going to be 8, I guess. Yeah, 8. So right now your sum is 8, but we are adding 4. 3, which is 11. So your sum is going to be 11. You understood, right? I skip 15. Now okay, so let's see now other case. Your sum is this way. Now let's try to remove 1. So I'll skip 1. When you skip 1, now what is happening is 1 has appeared 2 times because it is middle element. It has appeared here and it has appeared here. So this one you have to remove, and then this one you have to remove from the entire sum. So 15 minus 1 is 14. 14 plus this is 6, which is 20. And from the sum 33 you are removing 20. It's like 13 we have right now. But when you remove these, so now it's like 415 you have, it is there, and these two you have removed. Now from 7 9 you have, but this 15 and 7 is not taken into picture. So you will be adding 8 sum. So 15 minus 7 is 8. In 13 you will be adding 8. It is going to be 21. So your sum is going to be 21. Okay, 1 we have skipped. Now let's skip 7. So when you skip 7, this one you are removing, and then this one you are removing in the sum, right? When you remove 7, your sum will be 4 minus 15, which is there, 15 minus 1, which is there, and 1 minus 7 you can't take because there is no more 7. It's like now you have only 9. 1 minus 9 you will have added. So this 7, these two you have removed, but you are adding 1 minus 9. 1 minus 9 you are adding. So in the entire sum you are removing this, which is 6, and here you have 2. 8 you are removing. If you are removing 8, you will have 24 sum, and then you will be adding again 8 here because 1 minus 9 is 8. So it's 33 only. Your sum is 33. Now let's focus on the last one remove. So when you remove the last one, right? So see, if you remove this thing, you have only this array. 4 minus 15, which is here. 15 minus 1, which is here. 1 minus 7 you have here. But 7 minus 9 will not be possible because we don't have any element. It's like we have till 1 minus 7 only. So only this part will be removed, right? From the entire sum. So when you're skipping last element, which is 9, your sum is 2 will be removed from the sum, it is 31, right? So in this, if you see which is the least sum, it has got least sum here. When you remove 15, I mean it's like first floor, second floor, third floor, fourth floor, fifth floor. Okay. So if you skip the second floor, your sum is going to reduce. So this is the minimum value that will have to return. Okay. So when I give this simulation, what you have understood is that when you are removing, first you will have to make sure whatever said in the problem, like for given number of floors, or you can say for a given array, you will have to make sure take the difference between first the current element and next element. Current element, next element till n minus 1. Okay, I am taking one by simplifying. So till n minus 1 you have to move and take the differences. So you will have sum here. When you are removing the first element, you just want to remove first element minus the next element, right? Only this sum you have to remove, as is that here. And when you are removing the middle element, two sums you will have to remove. Which one? The previous and the current and next. And previous and next you have to add that absolute value. Okay, difference of those absolute value will have to add in this sum. And we'll have to maintain an answer variable, whichever is minimum, that will be updating. And when you're removing the last element, only the previous and the current difference absolute value will have to remove. Okay, I think you guys have understood. So let's see if we have 11 as an answer. Yeah, we have 11 as an answer. In this case also you can do the same driver and check it. Now let's solve it. So yeah, this one, let me try to solve in front of you. Let's see the test cases. We have test case, so I've taken care of this question, and for every test case I'm calling a sub function solve. And we have integer n, which is the size of the array. Then we have vector a of n, right? We'll be taking the values. Now let's maintain one sum variable. Yeah, it will be of type integer. We'll maintain one sum variable, and we'll run a loop till we'll move from 1 till n minus 1 I plus plus. Since in the problem statement they have given, it is 1 base indexing, but in vector we will be taking it as 0 base indexing only. So in the sum we will be adding modulus value, which is absolute value of ai minus 1 minus a of I, right? So this will give the sum wherein we have as we have not skipped any elevator. Now let's take an answer variable. So initially let's say answer is int maximum, because we have to make sure we are getting the least value. Okay, now we'll be moving from 0 till n minus 1. So if there are any elements in the array, so its index will be from 0 to n minus 1. Now we'll have to check if I is 0, which means it is the first element. As I said, if it is the first element, then your answer is going to be minimum of answer comma whatever sum is there. In that you will have to reduce the absolute value of a of I minus a of I plus 1, right? So I told you, like, whatever element we have, if you are removing the first element, you will have to take the sum and then remove the value of current element and then next element. Okay, I did this. Now else if I equals to n minus 1, which is like last element we are taking. So when we are taking the last element, so again answer will be minimum of whatever sum is there, absolute value of the previous element minus current element. Okay, else it is like the middle element we are having. If middle element, so it will be minimum of answer comma whatever sum is there. In that two sums you will be doing. First is like the current element whatever we have minus the previous. So it will be absolute value of a of I minus 1 minus a of I. Okay, and one more what we will be doing is current and then next absolute value of a of I minus a of I plus 1. And one more thing what we were doing is we were adding the previous and next different sum, right? So a of I minus 1 minus a of I plus 1. Since it is absolute, so the order of this thing will not take into effect. So yeah, let's display the answer. Okay, we're getting wrong. Let's figure out how it is wrong. Yeah, I got why it is wrong. See, we are starting from 1 based indexing and we are moving till n minus 1. Okay, less than n minus 1. This is like n minus 2, but we'll have to move till n minus 1. So yeah, it is getting fast. I think you guys understood, right? Here, it's like 0 based indexing. That's why I am taking the previous minus the current sum. So that's why I should move from 1 to n minus 1, right? So let's try to submit. Yeah, it got accepted. So in this way you could have easily solve the problem. I think you guys have understood. Basically the explanation part was understanding the problem was very important. Coding you can do in your own way. So yeah, thank you guys for watching the video.